In elderly people, their capillaries tend to be very leaky. So a high capillary permeability can lead to edema. So let's see how that happens. So here we have it. You have an elderly person with leaky capillaries, increased capillary permeability. This means more filtration, more water can easily leave the capillary at the arterial end. So we have filtration increases greatly. You have your two up arrows. If filtration increases greatly, then filtration is much greater than reabsorption. We can put two greater than signs to show that the filtration is much greater than reabsorption. When that happens, there is greater fluid accumulation in the tissue spaces. Fluid accumulation in the tissues increases greatly and the lymphatic drainage cannot keep up. And the result is edema. Let's imagine that you are treating a patient who has recently suffered a heart attack and now has pulmonary edema. So let's see how a heart attack can lead to pulmonary edema based on what you've just learned. So here's the heart attack, which is the real cause of the pulmonary edema. The heart attack may have affected the left side of the heart. So the left side is damaged. So damage to the left ventricle, which would lead to the right ventricular output being greater than the left ventricular output. So essentially we have unequal stroke volume. When the right ventricular output is greater than the left ventricular output, fluid accumulates in the lungs, which is basically pulmonary edema. A child who is a victim of starvation ends up with a swollen belly, which is really edema. So we're going to take a look at how starvation ends up in edema. So here we have a child that is starving, and as a result, the dietary intake of protein is very low because during times of famine, it is very hard to get protein. So when the dietary intake of protein is low, then plasma protein production goes down because there are not enough protein raw materials to make plasma proteins. When the plasma protein production goes down, plasma protein levels in blood go down. We've just learned that plasma protein levels have something to do with osmolarity. So blood osmolarity also goes down. When blood osmolarity goes down, reabsorption in the capillary also goes down. So when that happens, more fluid leaves the capillary than enters. So fluid leaves blood vessels. And this ends up with an accumulation of fluid, and we call this edema. Edema is sometimes a sign for kidney damage. So let's see how kidney damage can lead to edema. When a person has kidney damage, their filters in the kidney are destroyed, which means proteins are not filtered out and instead they appear in the urine. So there is a massive loss of protein via the urine in a person who has kidney damage. So when proteins are lost, the levels of plasma proteins goes down because urine is really filtered blood. So when the proteins are lost, the proteins in the blood are lost as well. So plasma protein level goes down. When that goes down, the osmotic pressure in blood goes down as well. So the blood colloidal osmotic pressure decreases. When that decreases, reabsorption at the venous end of the capillary decreases as well. And reabsorption is much less than filtration. So we will use two lesser than signs for reabsorption versus filtration. And as a result, the fluid accumulation in the tissue spaces increases, leading to edema. Lymphatic blockage leads to a massive edema. When there is a lymphatic blockage, lymphatic drainage goes down. And when that happens, fluid accumulates in the tissue space and causes massive edema.